we have the final presentation. Daniil Kireev, also senior researcher at VisionLabs. So the topic of the presentation is neural network video analysis of people movements. So earlier today, Sergey talked us about face recognition. What are the challenges? Now I will tell you about a different area, like recognizing and tracking people movements. Yeah, so let's begin with the task setting. We have a premise, like a shop with a lot of video cameras installed, and we need to track how people walk between the cameras, and there may be blind zones, and people may leave the zone, but the system should realize that this is one and the same person. So we do it without face recognition. Why? Because faces are not seen very well on cameras available at shops. And this approach is better and more pleasant in terms of using personal information, personal data. Let me show you the way it works. We have a little shop with 6 cameras, and we have videos here at the top left corner. And we need to build tracks on how people move. And at the right, you see that for any new tracks, so it's matched with all tracks we saw before. So if the speed rate is high, we realize that that is the same person, and we continue the track. Or if a person is not matched with anything, we build a new track. So this is how we build tracks of people moving around. So the key feature of our system is that we work with blind zones, that we don't require face recognition. It's not mandatory, and we work on cameras already available at the shop. So the goal is not to add new cameras, and all approaches are oriented on solving this goal. So this is an example of one camera. We work with production. We work at shops, at industrial sites. Well, another. So this is how faces are on those frames. If at least I can tell something about people from our office, I know them. But for the top slide, I cannot tell who are the people. So that's why we track people by appearance. But we can put a camera. If we noticed a face, then we can combine information for the face and the body. So if we take the face, we can identify the gender, the age, who exactly this person is. And if we add the movement algorithm, we can also add, we will get the information for the full track about the person. How does it work? So there are 3 stages. We need to find a person within the frame, and then you identify it. Then local tracking should be done within one camera, and we need to have a set of crops. If there is, if a person is visible, it's easy to resolve the problem. But if you have hundreds of people, like in an airport, with their tracks crossing, we add a new neural to improve the tracker on local camera. And the last bit, we need to define what local tracks belong to one and the same person. So we use matching algorithm for this. This is a pipeline very close to face recognition, as partially mentioned by Sergey. VAT ID, it's similar to face recognition, and we get the global track after we matched all the crops, all the bits, and we are guided by the appearance. It's not clear how end-to-end works here, but you see that the camera focuses on clothes, accessories, body build, hairdo, and it pays attention to tiny details. A slide which has already been shown earlier today, you see that algorithms for face and body recognitions are similar. And so you can understand if this is one and the same person, or you can identify a person within a database. So you begin with retrieving the descriptor, and then you find the distance between descriptors from different tracks we found on the track. So if the distance is small, then we believe that's one and the same person. If it's bigger, then with high chance they are different persons. As for naming, the three stages I mentioned, but it's called a multi-camera tracking, and our ambitious goal is to track a person in different environments. A person was to a shop, then he went out when he is walking the street, but we keep tracking the person. So multi-tracking, people at different cameras. Where can it be used? There are 4 big blocks where you can do it. Number one, a big one, customer stream, customer behavior. In online shops, we can track customer behavior. So if there is like an iron typed in a search engine, so then the person would probably go to the website and see the images and buy it later on. It all works well if we are online. In offline shops, it's much more difficult, but our ambitious goal is to offer that type of analytics. So if a person goes to a shelf with an iron, then it means that he's focused on a certain product. If then the person would take it into the hands, then he could probably put it into the shopping cart. Then, as a final, all algorithms used online could be also used offline to improve sales. And we can analyze movements of all buyers in a shop. We can build heat maps, like for heat mapping, and match the gender, the age, the race, everything we can read from the at face recognition. Those are global ghosts, but there are, well, it's clear that if you have one camera and a queue, but if there are big queues at stadiums, sports arena, and we try to count people at a game, then multi-tracking can use to exclude duplicates. We can analyze interactions between buyers and shop assistants. So if we come to a shop, I would not like to be bothered, but we can track whether the shop assistant came to talk to the customer, or more interesting, when client is at the shelf, is standing at the shelf with irons for 5 years without movement, so maybe it's the time when you have approached it. The next block about employees. Checking if regulations are observed. I talked about one case, but we can also not just shopping, but also industries. So maybe there are locations where an employee should stay or where sites an employee should avoid. For instance, there is a machine in operations and there should be no people around, so if there is a person, then we can activate an alert to make the person go away. And there are also complementary technologies, analysis of personal protection. If there is a helmet, vest, gloves on, just to avoid a person getting an injury. There are special zones in banks, in shops, where only staff is authorized to enter, no customers. The third big block is about security. In smart cities, in big cities, what can we do here? For instance, we saw on one camera that a person broke a car window and stole something. But we can track where the person came from. If we add this person to the camera list and analyze it in real time, we can probably find this person on one of the cameras and react to the situation quickly. There are social cases, searcher for missing people. The same as I called, but not a criminal, but a senior lady or a baby lost. We will be able to find it. The third case about security in shop. When a person enters, we can analyze the face and see that this is a shoplifter. If it's the case, we can either make him let go, or we can highlight the person's movement. So if it's a big store with 80 cameras, it will be highlighted. We will pay more attention to the person who is likely to steal. Yeah, that's a big block about security. And the last block about the relevant situation with COVID-19, we can use it for social distances, and we can monitor the number of people. So we have 4 big cases about multi-camera tracking, and I mentioned the personal protection equipment. This is a complementary technology, and multi-camera tracking is the foundation for analyzing what the person would probably do next. With face recognition, yeah, so you begin with highlighting a person and then analyze the track. Also, I will tell a little bit more about other complementary technologies. The first simple technology is projection to the premise layout. You scale every camera. You calibrate 4 or 5 spots and match it with the layout. So after the calibration is done, we can tell that the young girl is close to the shelf. And this is done, well, a case when just one camera is used. So at the left, a girl, Polina, enters. So she has a tracker STY on her hand. It shows her real coordinates in 3D space. It's shown on the map with the black curve, but we still keep tracking her. So we use that video tracking from the camera. It's in turquoise at the map, and you see that they are quite close one to the other. And we check the effectiveness of the visual algorithms. The tolerance, the error is of 40 centimeters maximum. So when a person would jump or wave the hands. So now let's use 2 cameras. We can see that the turquoise and black curves are nearly close to each other, and the error distance is 4 centimeters. And at the end of the day, what we can do, we can show heat maps and diagrams of people movement. It was a case in one of the shops where we were asked to assess ordinary buyers and the target audience of young men 25 to 35. So it was the movement direction was very straight. I think you can understand the meaning. And the last, another case, again, personal protection equipment. We detect people and we find if they have helmets, vest, and gloves. So they are highlighted in green if everything's okay. In red when there is something missing, and in yellow when we are not ready to make the decision.
And the last case is about people's attribute. As I have said, on the face, we can propagate this attribute from the face to the whole human track, and we can try to do it, and we are doing it all along the human body. And here is an example of what we can detect along the body, that is gender and age. It is clear that it is harder to detect the age on body than on face, but if we need wide categories like baby, child, adolescent, then adult, then old people, then it is more or less okay. Well, that is it, and there are 3 complementary technologies that I talked to you about. There are many more of them, and here are my contact details, and I'm happy to entertain your questions if we have time for that. Daniel, thank you very much. We do not have time, but we have received a question from 2 people that are watching us. So I will ask it. The question is, what is the accuracy and productivity of multi-camera tracking? Can it be done in real-time mode? Yes, thank you. So as for the accuracy, we have our own data sets, and we compare with the open data sets, and we look at the quality of each particular stage of a tracker and ID detector. We see how well it performs in open database. So we have hundreds of results. In ReID, we can show the hundreds of results. And in 17 milliseconds with 1% quality loss, the speed of work increases. So that is an answer about quality and speed. So the method that we usually show the client, give the client, works at 17 milliseconds, and the quality is close to hundreds. Thank you, Daniel.